All right, hey everyone. Now that we've gone over the algokit init command and how we can use a template to start our own project, and we've gone over the directory structure of the TEALScript template, so all these files, what these different directories do, now we can get started actually writing our own code. So we're just going to get started here in our contract. So again, this is the file that contains all the logic we're going to execute on chain. The template comes out of the box with some like calculator methods. So we're just going to delete those. We're not going to need those. And before we write our own methods, what I want to do is write some comments kind of explaining what we want to do. So basically, we want to define a proposal and make it easy for voters to see what the proposal is. Right? So a big idea of blockchain is transparency. And of course, if you're voting on something, you want to make sure that everyone's on the same page and you're all voting on the same thing. So what I'm going to get started with actually is a method called getProposal. And I'm going to return a string. And this string is going to describe our DAO's proposal. So what I'm basically going to say is return, and I'm going to return this is a proposal. Okay, so now when someone comes to our DAO, they're going to see that when they call get proposal, it's going to return a proposal. In our case, it's going to be this is a proposal. So if I do an npm run build here, and I take a look at our DAO.approval.teal artifact, we can see here that we have this get proposal string here, and that it makes it easy for voters to see what the proposal is, right? And has all the logic here that we need to do it. And the key thing here is that hard-coded is byte, this is a proposal. So if I were to go to my test now, I can come here, I'm going to delete the difference test, delete the logic here, and just call this get proposal. What I can now do is, because we import our DAO client, which remember, it's a generated artifact from TEALScript, or excuse me, it's a generated artifact from AlgoKit that contains a typed client that we can use to call our contract methods. So what we're going to do, and we instantiate it up here under app client, so we can just simply do await app client dot get proposal, and all of our function calls take an object. In our case, we don't have any arguments, so our object's just going to be empty. And what I'm going to do is I'm going to say that we're going to save this as const proposal from method. Right? So we have this object, and what we need to do is write a test. Say we're going to expect proposal from method, return in this return. So if this was a void method, it would be undefined. So in fact, in our case, we'll have this question mark to signify, to tell TypeScript that we know this might be undefined, and that's okay. Obviously, in our test, we don't want it to be undefined, but that'll show in this test result. And we're expecting our value of to be this is a proposal. Okay, so now if I do an npm run test, we can see here we create our app, and then our proposal that we got from our get proposal method is indeed this is a proposal, right? Exactly what we expected. And so if we were to change this, this is another proposal, and we were to go ahead and run this again, you'll see that it now fails expected this is a proposal, but we got this is another proposal. So that works great. So we've defined a proposal and we made it easy for people to see what it is. But I want to take this one step further and kind of think about the long-term use case of a smart contract. So smart contracts, as I mentioned, they're written in Teal and deployed on the Algorand network. And so whenever someone wants to call this contract, basically what's happening is that this code is getting executed. And this has the proposal hard-coded in it. But what if I wanted to make two different DAOs using the same code? Well, right now that's technically impossible because by changing what my proposal is hard-coded to, I fundamentally change the code of the contract. So what I want to do is make a way for the proposal to be set without directly hard-coding it in my contract. And to do that, we're going to use what's called global state. So on Algorand, any contract can save information to the chain. And there are multiple different ways you can save information. There's global storage, local storage, and box storage. But today we're just going to be focusing on global storage. So to get started with global storage, all we need to do is if we come to the top of our contract here and we define a property in our class, and I'll just call it proposal. And this proposal value, I'm going to initialize it using this global state key function. Okay. And what this is basically saying is that our proposal is going to map to a key that holds a global state value. So when we say global state or global storage, what's actually happening beneath under the hood is we're saving a key value pair in our contract. So on chain, we'll have various keys mapped to their respective values. Now, one thing we need to do, and this is one difference between TypeScript and TealScript, is that some methods require a type. So here what I'm going to do is I'm going to add a type argument, and I'm going to say that this global state key is going to be a string. In other words, proposal is going to hold a string for us. So now what I want to do is when I first create my contract, I want to set this global state. So I'm going to add a new method definition here, and I'm going to call it CreateApplication. Now this is a special method name. You can see here, so I'll define the signature, and then if we hover over it, you can see here that this method is called when creating the application. So if I come to create application void, and in here, I want to update the value of proposal, I'm going to simply say this dot proposal dot value equals this is a proposal. And then down here, I'm just going to simply update this to this dot proposal dot value. Okay, now it's important that we always remember this dot value. So if I were to just try to set this as this proposal, it's not going to work because this proposal itself is a global state value object. So to get to the underlying value in the global state key value pair, we have to call dot value. Okay, and so now that we've set our dot value, when we create the contract, so if I go ahead and build npm run build, when we create the contract, we're setting our proposal, and when we return it, we're going to be, returning it like here. Now the obvious thing is, I said one of the reasons why we want to update this proposal mechanism, and actually before I get to that, where was I just typing? npm run test. Let me just run the test to show that this is still working. And give it a second. Okay, so our test ran, our getProposal function, and our creation is working as we expect. So let me explain kind of why we're using global state. Actually, I already explained that one of the reasons we're using it is that we want our contract to be able to change without the underlying code to change. So we didn't want to hard code a value, but right now you can tell we're still hard coding a value. But because we have this state object, you can maybe start to think of ways we can avoid hard coding this value. So for the next video, we'll show you how we can get away from hard coding this value. But if you want to try it on your own before we go over the solution, I'd recommend you think about how we can change this CreateApplication definition to allow a dynamic value. So in other words, allow our code to stay the same, but the person calling the code has the ability to change what this function is. Again, you don't need to do this. If you're just watching asynchronously, you can just go right into the next video that shows the solution. But I just want to give you an idea of where we're going in the next video. I'll see you then.